Good morning, grade 12. Today, let's return back to physics and let's just start to talk about motion with constant acceleration. When velocity change by the same amount during each time interval, acceleration is constant. Constant here mean the increase in the velocity is the same time all the time. For example, the acceleration 10 change to be 20, change to be 30. The increase in the acceleration is 10 for every second. This means acceleration is constant. Okay. Also, the relation between displacement time, velocity, and constant acceleration are expressed by the equation shown on the next slide. These equations apply to any object moving with constant acceleration. هناخد الصفحة الجاية 3 equation. They are very important to study the motion with uniform acceleration. These equation use the following symbols. هتلاقي فيهم السيمبلز دي. Delta x, which mean displacement, the change in displacement. V sub I is the initial velocity. V sub f, the final velocity. And delta t, the time interval or the change in time. These are the equations that study the motion with uniform acceleration or constant acceleration. The first one, delta x, distance, equal half vi plus vf multiply delta t, or we can write it as delta x equal half vf delta t. The second equation, vf equal vi plus at, and the third equation طبعا الايكويشن في الحاله هنا لما بيكون الستارتنج velocity is zero، لكن هنا if we have a starting velocity او initial velocity delta x equal vit plus half at square and vf square equal vi plus 2ax. الثلاثه دول هم اللي يهموني، الاولانيه دي مش مهمه قوي، الثلاثه التانيين دول. طبعا if we use vi as zero الايكويشن بتبقى بالمنظر ده، vi zero يطلع الايكويشن بالمنظر ده وهكذا. اوكي. طبعا انت عشان تحل اي مساله using this equation، انا مش هتكلم على البروف بتاعهم، انا هكلمك على ان انت لازم تكون عارف ال 3 equation. يبقى انا هحفظ ال 3 equation اكتبهم قدامي في الورقه وابدا اشوف المساله هتحتاج انهي واحده في الثلاثه. Okay, simple problem. Final velocity after any displacement. A person pushing a stroller start from rest، يبقى ال VI equals 0, uniformly accelerated at a rate of 0.5 meter per second squared. This is acceleration. What is the velocity of the stroller after it has traveled 4.75؟ هو عايز ال VF ومديك التايم مديك الديستانس 4.75. اوكي، يبقى اول حاجه بنطلع البيانات اللي عندي وهي عباره عن VI start from rest acceleration equal كذا والديستانس equal كذا. اللي هو عايزه ايه؟ هو عايز VF. طب ايه الايكويشن من الثلاثه اللي فيها الاربعه دول مع بعض؟ هنلاقي عندك choose a coordinate system the most covalent one، مش عارف ايه، the positive direction to the right. هياخد دايما ال positive right وال negative to the left. الايكويشن اللي احنا هنختارها هي دي، فيها ال VF وال VI وال A وال X، فاقدر اجيب منها ال VF. هنعمل arrange الايكويشن ونطلع ال VF يبقى square root of the rest square root of the rest، ونبدأ نعمل putting numbers. هيبقى VI square بزيرو وال A 2AX، ادي 2 وادي ال A وادي ال X. هنجيب square root للريزلت ده، هيطلع VF equal positive 2.18 meter per second، وهو ده الريزلت اللي هو طالبه في المسألة. Okay, evaluation. The stellar velocity after acceleration for 4.75 is 2.18 meter per second to the right. Right ليه؟ عشانها positive مش negative. Okay, section 3. Section 3 have many things to talk about. Let's start with free fall. Free fall means if you let an object fall without air resistance. Let's take a look for the following video. Okay. Now the following video will explain how free fall happens.
A falling object accelerates at a constant rate due to the force of gravity. As the object falls, the velocity will increase at a constant rate. The free fall acceleration due to gravity, symbolized by the letter G, is 9.81 meters per second squared at the Earth's surface. If only the force of gravity is acting on the object, then the motion is known as free fall. Air resistance is a force that slows. A falling object accelerates at a constant rate due to the force of gravity. As the object falls, the velocity will increase at a constant rate. The free fall acceleration due to gravity, symbolized by the letter G, is 9.81 meters per second squared at the Earth's surface. If only the force of gravity is acting on the object, then the motion is known as free fall. Air resistance is a force that slows a falling object. That is why a falling object can only be in free fall if it is in a vacuum. If an object like a spacecraft is in free fall, the occupants inside will also be in free fall and appear to float.
Okay, so let's imagine that you are moving with the speed of free fall, which is 9.8. It is the acceleration of Earth's gravity. In this case, let's imagine that you are in a lift elevator, and when the elevator goes down, you feel that your weight is less. If you are standing on a balance, you will see your weight is less. Also, if the elevator going upward, you feel your weight is more due to the motion of the elevator is in the opposite direction of the gravity. So what about if the lift going downward and its speed exceeded the 9.8 per meter per second every second? You will feel your body float inside the elevator, and we call this the free fall motion. This happened in the space. When the spaceship moved, and as a free fall, moving was 9.8 because it moved under the gravity acceleration. In this case, all space astronauts fly inside it because they don't have weight, or we call this weightlessness. Okay, so the free fall is a motion of the body when only the force due to gravity is acting on the body, no air resistance. The acceleration on an object in free fall is called the acceleration due to gravity, which is 9.8 meter per second square, or free fall acceleration. The free fall acceleration is denoted with the symbol g or ag, generally g on Earth's surface. Let's watch the following video.
In the 16th century, Galileo theorized that if there were no air resistance, all objects would fall with the same acceleration. Let's drop two objects into a room that has had all the air removed. A camera and a strobe light reveal that the two objects move together at all times. Notice also that the two objects move a greater distance during each time interval. The distance between two successive images is proportional to their velocity during that interval. So you can see here that the downwards velocity is constantly increasing. In a full second of fall, the velocity will increase by 9.81 meters per second. The acceleration caused by gravity near the surface of Earth is therefore 9.81 meters per second per second.
Okay, as you see here, and I show you before a video that show that acceleration due gravity is 9.8 for every object. So the feather and the apple without air resistance supposed to reach the ground in the same time. And this the same as Galileo experiment happened when he threw two cannonball from the top of Pisa Tower tilt, our incline tower Pisa, and they fall together in the same time to the ground. The two cannonball was not having the same mass. One of them is full and the other is empty. Okay, free fall acceleration is the same for all objects regardless of mass. This book will use the value of 9.81 meter per second square as g, or the gravity acceleration, gravity due acceleration. Free fall acceleration on Earth's surface is 9.81 meter per second square at all points in the object motion. Consider a ball thrown up into the air. Moving upward, velocity is decreasing, so we use 9.8 with negative. If the object moving upward, we use negative 9.8. If the object moving downwards, move with positive. Okay, at the top of when you throw ball upwards, move negative 9.8 until it reaches the top, which the speed equals 0. Then it returns back with a positive 9.8 acceleration. Let's watch the second video.
Let's toss a ball into the air and think about its velocity and acceleration as it travels. When the ball is first tossed into the air, it is moving quickly upwards. It slows, then changes directions, and speeds up again on the way down. Let's look at this again and focus on the velocity. Suppose the initial upwards velocity is 20 meters per second. As the ball travels upwards, the velocity slows. Let's freeze the motion at the top. At this point, the ball is no longer traveling upwards, so it does not have a positive velocity. However, it has not yet started moving downwards, so it cannot have a negative velocity either. The ball must therefore have a velocity of 0. Next, the ball starts to descend and gains speed as it travels. Let's throw the ball one more time and graph its velocity as a function of time. As you can see, the velocity changes smoothly from upwards, positive, to downwards, negative. Remember that acceleration is the slope of the graph of velocity versus time. You can see that the velocity graph has a constant negative slope. This slope is the acceleration due to gravity, negative 9.8 meters per second squared. The ball has this same acceleration at all times, even as its velocity is positive, then briefly 0, then negative.
Okay, back to the PowerPoint. This will be everything for today, moving a ball upward and moving back again. We will continue describing the free fall acceleration next session. Thank you for your time. Until next time, please say goodbye.